In this lecture, we will see briefly the electrostatics of conductors. So, what happens in conductors when there is some electrostatic field? So, as we all know that the conductors have load many free electrons, which are free to move uh, in this conductor, but they are not free to go outside this conductor because of the force on the surface. So you see that electrons are free to move anywhere in this conductor, very free. They can go at very fast speed, or the effect can be very fast, but they cannot go out of this conductor without some thermionic emission or something like that. So whenever this conductor is brought in some electric field, okay, so what will happen? The electrons will move such that they try to neutralize this electric field, because this field will create force on those electrons, and these electrons will move such that they will neutralize this electric field, and there is no electric field inside the conductor. And this movement of electrons happens very fast, within the fraction of some milliseconds. So this phenomena is very fast. As far as the statics part of the electromagnetism is concerned, so this conductor is having a property that the electric field inside this conductor, inside means this meat of the conductor, let us say there is this cavity, so this is the inside of the conductor, this is the meat of the conductor, okay, at any point inside this conductor. So this field is equal to 0 according to the distribution of the electrons on the conductor. So this is the property which the conductors will follow in an electrostatic field. Now, because of this very interesting property, so many interesting things are going to happen when conductors are placed in the electrostatic field. So let's see what happens inside the conductor. Now let us say this is a conductor and this is an electric field, electrostatic field, and this conductor is now brought inside this electrostatic field. So as I told that this E is equal to 0 inside this conductor. Now E dot ds circumscribed by the surface of the conductor is equal to 0. Now this E is 0 because it is 0. It implies, how do we charge this conductor then? Electrostatics. How do we charge it? So this thing means that all the charge, if somehow appears on the conductor, it is not going to be inside the conductor. It is going to remain on the surface of this conductor, and this surface thickness is just 1 to 2 atomic layer thick. That is very small, very thin layer. This layer will going to have that charge, and inside this conductor there will be no charge because of E dot ds is equal to 0, and this E is equal to 0, so there will be no charge. So because of this property, the inside of conductor is not going to have charge, and all the charge which is there, which will come to the surface, or the surface means the 1 to 2 atomic thin layer. Okay, so this is what it is. Now what happens when we let us say assume that there is some component of the field which is tangential to this surface. Let us say this is the conductor, and the field, electrostatic field, is having some component along this tangent, uh, along this surface. Okay, so it means that it will create a force on the electrons on the surface, and these electrons will again start to move to neutralize this electric field. So in a sense, we see that on the surface of the conductor, the field cannot have any tangential component. So field should always be normal to the surface. So again, this is a very important property of the conductors in electrostatic field, that the surface of the conductor, or the conductor itself is equipotential because E is equal to 0, so there will be no potential difference. So this whole conductor is equipotential, and the field will be perpendicular to the surface of this perfect conductor or the conductor in the electrostatics. Now, what about if there is this cavity inside the conductor? So if the cavity is symmetrical, that is this spherical symmetry is there, and this is the conductor part, and this is empty, this space is empty, means air or something, nothing else, or vacuum. And the conductor, though, let us say copper aluminum, is inside this only, this portion only. So by symmetry we can see that E dot ds is 0, and since there is no charge in this cavity, and since by symmetry direction will be radial if it is there, so E can be brought out to be 0, and this ds cannot be 0. It implies E is equal to 0 in the cavity. So by symmetry we can see that in spherical cavity the electric field is 0 in the conductor if the cavity is empty. However, what if this cavity is of arbitrary shape? There is no symmetry is there. So what we can expect out of it? Again, if this cavity is empty, you can surely say that the field inside it is 0. How do we say that? There is no symmetry, so this part E dot ds is equal to 0 is not going to give you the correct, means the complete answer. It is going to give you that this E dot ds, let us say I make a Gaussian surface which is inside this conductor meat. Okay, so it will mean that E dot ds is equal to 0 implies that the total charge inside this Gaussian surface is 0. So there may be a scenario that there are this plus charges, and then this is minus charges on this inner surface. This is the inner surface of this cavity. So some part of this inner surface is having plus charge and some part is having minus charge, and these two both are going to sum as 0. Okay, so this can be the case because this does not imply that the charge or there is no charge. There can be oppositely equal charge. The total charge can be 0. The Gauss law just comments on this thing. It does not tell you whether it is really the situation. But really, this is the situation that there cannot be any charge on the inside surface of the cavity. If this cavity is empty, like this cavity is not having any charge placed intentionally inside, then we can clearly say that this inner surface of this cavity, this inner surface is not going to have any charge. Why is that so? So let us see. Let us again make this cavity. Okay, so let us assume that this cavity is having plus charges and minus charges on the inner surface. Let us see. Because Gauss law states the total charge is 0. So what happens? This will create a field which will emanate from plus and go to minus, and it will complete path from here. Okay, so this is inside the meat. So this E dot dl across this curve, this is path 1, this is path 2, is equal to E dot dl across path 1 plus E dot dl across path 2. Now we know that in the electrostatics E dot dl is equal to 0. That is because since electric field is conservative in nature, it does not depend on the position, on the path. It just depends on the position. So we see that this should be equal to 0 in a closed path. But for the path 1, this E is equal to 0 because it is inside the conductor. So this part is 0. Now only thing is E dot dl for the path 2 should be equal to 0. Now this will be 0 if and only if there is no field inside. Okay, and there are no charges inside. The field will not be inside only if these charges are such that these have intermingled with themselves and cancelled each other. they are not just distributed like as dipole or something. So you see that this conservative property of E dot dl or the electric field is forcing that any charges which was on the inner surface have intermingled with each other and cancelled each other. Now there is no charge on the internal surface of this cavity. So in this way we have derived both part, that this field inside the cavity is zero if there is no intentional charge put inside the cavity, and there cannot be any charge on the inside surface of this cavity, be it of any irregular shape. So this concept is used in the electrostatic shielding. That is what happens that mm, no matter what kind of electric field is outside, this is the electric field outside, if there is any cavity inside, you can put any object and it will be independent of this outside electric field. It will not get affected by this outside electric field, because as we have already proved that this field is not going to have any effect on this cavity. However, if this cavity is charged, this object is charged, it will create a field. Okay, and this field will be seen outside, and this field which is seen outside will be independent of this outside externally applied field. Okay, so that is a different thing. But if this cavity is empty, and again, even if it is not empty, this inside thing is going to be independent of the outside applied electric field. Now there is a scenario, if I ground this conductor. Now if I ground this conductor, in that case, even if I put an electric charge inside the cavity, now this external thing is totally isolated or shielded. This is shielded from the external and this is shielded from the internal charge. So this is how this electrostatic shielding works. This is electrostatic shielding. So in this way we have seen that this electrostatic shielding, how it works. So you see this E is equal to 0. This part is making these two independent. This thing and this thing are as independent. So this property will be utilized in some of the examples or practical things. So this is very important that we understand this concept which I have just explained. And if you don't understand this concept, I request that you watch this video again and again. So if you find that this lecture is helpful to you, then please share and subscribe our YouTube channel, and also join us on our Telegram group, whose link is given in the description of this video. Thank you.